So, good morning, everyone.
Good morning, sir.
We have come to day number 5. That it must be hectic for you all these days. You
It
can,
was not
un-
hectic, but it is a very interesting workshop actually. Yeah. We are learning a lot.
you learned a lot. That's a
Yeah.
very nice compliment, sir. Generally, everyone reduces the online timing. We have increased it.
No, but it was quite interesting, sir. Especially for
Yes, sir.
mechanical engineering aspects. We are really learning very good things.
Yes. Actually, you know that one thing engineering is not a single discipline. Actually, if you take
E-
any system,
Exactly, sir. Exactly.
it is not a one thing that you mostly engineers they do those things, but they have to know the system. Otherwise, what they will how they will tackle the issues. If
Right, sir. Right.
one does not know the system, can they control it? Can they process it? It is
Right, sir.
not possible. So interdisciplinary approach that must be there. That they must know where what they are making, for whom they are making. So these things must be there.
Absolutely true, sir. Right.
There is a famous ad is there that uh, Kirloskar pumps are there, na? So
Yeah,
that
yeah.
one set of engineers are nearby a pond, and then they are saying that this is impossible. We can't have this project. So what we'll have to do? We'll have to relocate this pond.
Oh, oh my God. No,
So
the pond should not be. It cannot be
ah,
relocated.
so then they said Kirloskar is there because
Yeah.
Kirloskar pumps are high quality, and you know it's in terms of quality wise, customer satisfaction is quite good for Kirloskar pumps.
Yeah. I agree.
They
I
are
agree, sir.
so they are market leaders in that for
Right.
India and world.
Right.
So today we'll have 3 sessions. There is slight change. Morning session will be taken by Dr. Amit Singh, and he will be most probably engaging the afternoon session also. That we have added added one more session to you, and in between 11:30, we'll practice some more of LabVIEW again once more. Okay, so that on the
Right.
last day again you have practice, and we'll design something that so that it encompasses all the aspects whatever we have learned, so that our practice will be little more again, right? And finally at 4 we'll have also one short quiz that it will be uh, Google form based. It will have around you can say 10 questions, multiple choice kind of. So all of you have to attempt that. So the questions will be covering all the various expert lectures. Maybe you can expect around one or two questions from each. So 10 or 20 questions will be there from each one of them.
Right.
Okay.
Right.
Total 10, 20 questions will be there. It will be multiple choice, very basic. You need not worry that you can make out. And finally, we'll have valedictory function at 4 p.m. So these are the plans that for today. We'll be joining shortly by Dr. Amit.
Hello.
Hello, good morning, sir.
Good morning. Yeah, we can start the session now.
Yes, I'll start. So, good morning to everyone. Uh, Let us welcome Dr. Amit Singh. He's an assistant professor in mechanical engineering department of MNIT Jaipur. Dr. Amit Singh has done BTech in mechanical engineering from Kurukshetra University, MTech in manufacturing systems engineering from MNIT Jaipur, and PhD in mechanical engineering from BITS Pilani. Dr. Amit Singh has over 13 years plus experience in teaching and over 8 years of post PhD experience. Dr. Amit Singh also has more than 24 journal publication in his credit, and the total number of journals and conferences, international conferences, amounts to 30 plus. The main area of interest of Dr. Amit Singh are biomechanics, additive manufacturing, rapid tooling, and his research profile says he believes in delivering to society and industry through research. He planned to make research quantifiable and deliverable through working in the areas that are of practical significance to society and industry. Presently, his research group is working on CAD-based customization of post-thesis socket, design and development of hip implants, rapid tooling, geometric dimensioning, and tolerancing and sustainable manufacturing. So with these words, let me welcome Dr. Amit Singh for you. Good morning, sir.
Good morning, and thank you, Dr. Parikshit, for such an elaborate introduction of me. And I'm sorry, I would like to seek or ask for apologies from all the participants because this session was supposed to start at 9:30 and it's a bit delayed. So please pardon me for that. And Dr. Parikshit, is my sound okay? Everything is
Yes,
fine?
that your sound
Okay.
is okay. Yes, I have
Uh,
made you co-host and presenter.
Okay, so from where do I get this option? Because I'm using
Uh,
this platform. So
Downside there is a share button, sir.
okay, yeah, got it. So because I was on my camera, so okay, yeah. So I think now the screen is being shared. Is it visible?
Yes, it is visible, sir.
Okay, so thank you. And today this is the last day for this course, and I congratulate myself along with Dr. Parikshit because we are jointly with MNIT and Triple IT Quota, we are organizing this course. And I've seen through schedule, so you have like lot of hands-on, and means it was all very intensive sessions. So today it's going to be not because I being a mechanical engineer, so I am not, I should say that hardcore person like Dr. Parikshit, but something that we are looking forward to is so let me come to here. So then the question is what next, right? So you have this 4 days of training. Now, as we say that anything for any course or whatever training you are doing, so what is the takeaway that you are going to have from this program? So ultimately, the idea was that I'm not more of theoretical person because if even LabVIEW, so we were kind of shying away from all those sessions of LabVIEW because like we are not being a mechanical engineer, so it always gave me some kind of fear to do all that programming and other things. But again, coming back to that question, what next? Like you have 4 days of this intensive training, today being 5th day. Now we have to look at like, so how do you take it forward? So I'm just going to play a couple of quick videos here. And so the idea is, of course, related to the topic of today's presentation, that is sensors and actuators. So in fact, I believe you must be wondering when Dr. Parikshit was reading out my biodata that how is this related to this course, right? So yes, like he mentioned something about prosthetics, that project, or we started working biomedical. So we are trying to look at the application of the sensors, and in fact, we started a lab at MNIT Jaipur Instrumentation Lab, where we have all this NI data acquisition system, and Dr. Parikshit, he is also working with us. So okay, so the point here is like these videos. So of course, like I also, without permission from my son and my, of course, my PhD student, he knows about this. So I've used their videos. So this is something like we had been doing during this lockdown period. So I'll quickly play these videos and then I'll come to the discussion. So the so this is the first video. So I have like muted the sound there because my son, he did not want anything. And Dr. Parikshit, is video playing everything okay?
Yes, sir. Yes, sir. It is okay, sir.
Okay. So, okay, this was the first video. And like the point that I was trying to say here is that you can see, of course, a very simple system that we had been talking about, this hand-free sanitizer dispenser. So, because like when you press the sanitizer bottle, so that itself is like getting contaminated and you are using it. And it's a very simple system like what you are seeing here in this video. Of course, this was done by my son. And so the point that I'm trying to say is that sensors and actuators, like right from the hobbyist to the third video that you see, to a person who is using it for the research purpose. So how do you actually go about these sensors and actuators? Now, so the first video that we had seen, so he had used all the simple stuff, that is like, you can see this is a simple tube, and then he has used a pin cap for there, and then this is the sensor over there. So what it does is that as he places his hand in front of the sensor, so basically this is the sensor and the actuator is lying inside the bottle, that is a submersible pump. So basically you are seeing that there is some form of convergence that is taking place. So sensor, it is actually detecting the distance. So as he places his hand in front of this sensor, so as you see so this is already activated, and as the hand is placed in the front of sensor, so it detects this, and then it sends an electrical signal or input to the pump which is there inside the bottle, and then it converts that electrical signal to a output, that is, say, the pressure. So electrical signal is being then converted to the mechanical energy, or in the mechanical form, and that's the pressure, and then the liquid, it starts getting dispensed out of it. So this was one sensor that he tried. Then he said that, okay, of course, like my son, he is studying in 8th standard, so it's not something, so you may be, so for his age, I think that is a good amount of work. So he got interested. He said that, okay, let me try some more sensors. So this was the second thing that he tried. And again, like he's using all the stuffs that were placed at home. So he has used this Pringle bottle, and then this is a straw. Again, the pump is there inside. So in fact, instead of, the first sensor that you saw, that was IR sensor. Here he wanted to use that ultrasonic sensor. But somehow that ultrasonic sensor, means it is there with me, I can show you that kit, but that video somehow was not available with me right now. So So this is like you keep on trying with like when I say infrared sensor and ultrasonic sensor. So what is the difference? How does it make a sense? And then the other thing that you have learned in this course is about the Arduino board. And then you, since this whole program was about LabVIEW, right? So that means you are doing some kind of programming. And then, so of course, these sensors that you look here, so it does not use any LabVIEW or any kind of programming like this. But then, like you have, we talked about these Arduino boards. So I have one here with me. Dr. Parikshit, actually, I cannot see myself that what is the visual. I do not know whether what I'm showing is it being displayed to everyone.
Yes, sir. It is
So,
getting displayed.
this is the Arduino board. Now the question is, of course,
Amit sir,
yeah.
I think you can turn on your video also. I think.
So video, is it not on?
I think
Okay.
down you
Right.
start video.
Because it's already gives me so I get this option stop video. So video was already on. So now as the video
I'll just see.
Sir, actually, video is not on, sir, right now.
but in my window it shows the video. I can see the camera on. Okay, stop video, and it gives connect to video system. Okay.
It is just showing that yes symbol, sir. Amit co-host.
Oh, okay.
Actually, it was sharing screen, maybe because of that.
So I think, yeah. So maybe the two things are not allowed at the same time or something.
Maybe if you share only this.
Yeah. So I think it doesn't allow to have video and screen sharing both at the same time. I never tried this one, so that's why I was asking this thing. Nevertheless, it's not very important. Shall I click on this join meeting option that comes? I don't know what. I just clicked on join meeting now.
Okay.
So now is my.
To mobile you are joining.
Okay.
Sir, you have joined 2 times and we are hearing echoes. So just leave from one side, like
Okay,
in which you are not the co-host.
Okay, fine. So better I'll just take this one now.
It is coming. It is coming now, sir.
Now the camera is there and screen is also there. Both.
Yes, both
set.
are there.
Okay, fine. Thank you. So yeah, now I can see myself in this. So what we were talking about is that we had seen like use of some sensor and actuator in the first two videos. Then my son, so he only like he was suggesting me that somehow he explored, and he said that because in the first case, as soon as you remove the hand from from this in front of the sensor, so it automatically gets deactivated, and then it stops supplying liquid or that sanitizer or whatever is there. So the point is that if you have seen those dispensers, sanitizer dispenser, and there is a cutoff time, so say 10 seconds or 15 seconds. Now, with this kind of a system that you see in the first video, so that this system doesn't allow you to do that thing. So if I look at this system here or the second system, so it is by default that as when the hand is placed in front of the sensor, so it gets activated, and then this pump switches on and it dispenses the liquid. But as you remove this, so then it gets this gets switched off. So the point was that even like when this is there, so if we could give some cutoff time. So how do we go about controlling this system, right? So for that, of course, you need a microcontroller, and that's what we were talking about. Like, so you have, I think, Mr. Vineet has covered something on Arduino. So we explored that these kinds of or this Arduino, which comes in like Nano, Uno, and Mega. So these are the three boards. So it has this. So this is a microcontroller, or it acts as a microcontroller. And the point here was that if the same thing, if you want to improve it further, that is, if you want to give some cutoff time, that is automatically after say 10 seconds, this should switch off. So there you need to get this kinds of microcontroller. And uh, now we had this. So the good thing is that this uh, Nano. So this one is the Uno, or so it comes in like Nano, Uno, and Mega. These are the three boards that are there. So these are not very expensive, and these are being powered by. So you have seen a USB slot, so you connect it with your desktop, laptop, and so it generally uses this 5 volt. So either you can directly connect a 9 volt battery to this, or you can connect it. So that 9 volt battery, so it automatically switches it to 5 volt, and or you can connect it to the computer. So so like hardware and software. So again, all these sensors that you see, so like these are compatible with these Arduino board, and you can also get. So again, this Arduino is a open source thing, right? So for different sensors, when you want to program these different sensors, so you can easily get the Arduino code from the source code, or it's again a open source thing. So we also got this kit. It's again available at Amazon. So this is like Sun Robotics, and something like the Arduino board was for some 500 to 900 rupees. And this kit was again maybe I think around 1800. So it has got couple of sensors over there. And the good thing is that all these sensors are actually as we were saying, so you can program it with Arduino, or you can so these are compatible with Arduino. So this was like the breadboard, and then this was this ultrasonic sensor, and this is a servo motor. So we have these sensors and the actuators. Now, of course, here we have, so in this case, we had seen this is the sensor, and this was the actuator, that is the pump, which is converting that electrical signal to the mechanical pressure, and then this is forcing the liquid out. And now let's come to, so this is something, the sensors and actuators for a hobbyist, like my son. And if we again move forward, and we see that, okay, how do we use, so can we really use these something low cost sensor, something which would cost something from 100 rupees to so these are very inexpensive. So anyone can start working on these sensors and actuators using this. So you don't have to wait, because it doesn't need much investment. Now let me play the other video. So this is going to be more professional, and here what we are trying to demonstrate is that how do we use these sensors for the actual research setup. So I'll explain this later on. So he is Mr. Radhesham Rathore, my PhD scholar. So you can see that he's walking with some kind of system latched to his leg. And I have that system here with me. So then after that, he also had a switch, or he had like made a switch for it, and then these parts were 3D printed. So this is the complete system, and this is like you can see here. This is the sole that was placed. I'll repeat the video. So this is a sole, and in the sole we have placed some sensors, and then we have some sensor in this block that you see over there, and another sensor over here. So it is like we place some couple of sensors in this whole system, and then you can see that he's getting some output on his mobile phone. So, and this is say the battery that he is using to power this whole system. So he is using a Bluetooth module, and using this Bluetooth module actually, so the output of the sensors, it is being transferred to the to his mobile phone. Now, what exactly what we're trying to do in this is, so what happens that when you walk, so there is certain pattern that is like place your feet first, and then your the complete foot comes in contact, and then first we place the heel, then it's the whole feet that is placed on the ground, and then we call, so it's called as a gait cycle. So there are different phases: heel strike, and then stance, and then toe off. So basically, what we are trying to do is we are trying to measure that as the person starts walking. So what is the force that is being transferred from the ground to the body? So sensors are being placed. The Flexi force sensor, we call that as Flexi force sensor. That comes later in my slides. So we have placed the sensor inside this. So you can, I think, see over there. So this is like the sensors that are being placed inside the sole. Then we have something like, so one was that you want to get the forces that are obtained from the ground, or like as the person walks. So the forces are being exerted on the body. So now if the person gait is not proper, that is he's limping from one side to the other side, so what would happen is that there would be uneven distribution of forces on the two legs. So in this case you have seen that it is only on the one such leg. So say the person weight is around 80 kg, and then you want to see that what is the load being distributed on like one limb. So first part is you get the forces, or you get the distribution of forces. Then second thing is that you had seen the system that there is something strap on this above the shoe. So the sole was actually placed inside the shoe, but there is also some strap arrangement which is there on the so you see over there. So this is another strap over there. So this is something like this. So you have a sensor in these two straps. So again, and these are nothing but accelerometer and gyroscope. Now what they are doing is, again, these are low cost sensors, that is something ranging from 300 to 400. So the idea here was that when the person walks, so one thing is about the forces, that how the forces are exerted from say the ground reaction forces. Then other thing is that as this person is walking, so there would be some trembling. So it would not always be just in the straight position. So it may be like some tilt in the angle, or there would be some angle. We call it as inversion or eversion. Similarly, for the knee, we want to see that whether this knee is like kind of getting displaced out. So the other sensors, what they are trying to do is they are measuring the joint angles. So if there is something like a displacement of these joints, so how much is the displacement, or what is the angle by which this is being turned? So here we place, in the sole part, or in the sole, we actually place some sensors. These are the Flexi force sensors. Again, these are MEMS sensors, so they are very means inexpensive. And again, here we place some accelerometers and gyroscope. So that was which we call as the inertial measurement unit. So that is basically to get the joint angles. So we are talking about two things, that is forces and the angles. So we are measuring the forces and the angles. So we had seen in the first video something like very simple system with the sensors and actuators, and in this we are looking for something complicated, or if not very complicated, good enough setup that can help you to do your research work, right? And so good thing about this is that you can get started anytime. And again, then let me show you the output here. So what we did next was that I have in my mobile phone, so this is an app that I have installed. So this is a serial Bluetooth plotter. Then I connect this. So this is already switch on. So I connect this device using this Bluetooth. So once it is connected, then okay, so I need to just switch it off again, and I'll switch it on, restart it, and yeah, so this is connecting to the system or to the Bluetooth module that we had over there. And once it is connected, so then if not here, then I can show you in this video at least. So you can see some values being displayed, right? So you can see the values being displayed on the phone. So these values are actually nothing but these values are whatever measurements that we want to take. So there's the reaction forces and the joint angles that we are talking about. So we are getting all those values. Now, how do we connect this to whatever what we are doing here, and then what's the like that's what I started. What next? So you have done this LabVIEW, and so now the problem for this data that I am acquiring from this complete setup. So the problem that is there is that it is giving me a continuous data. So it is like if I want to time this data, that is I do not want, so because this whole thing would become, it would be a big Excel file. So, and I really do not require this data continuously. So it is, so if I want to program this, that what is the time interval after which I want to obtain this data. So I can do all this with the programming that you have seen or like you have done. So even it is something like when you can again go for the advancing, you can do signal conditioning, and if you want to program it. So means in this particular case, the other objective is that I do not want this data in like such continuous. So I need it at certain time intervals, or it is something like when the person places his feet and then so there is some time lag. So how do I obtain that thing in that manner? So that is the whole idea about uh, this work or the whatever I was trying to display over here. And so that brings me back to from where we started, that what next. So now you can see for yourself that these sensors, so all this thing is available, and then you can use the Arduino, and then and of course you have like now good experience in the view. So coming to the formal part of the presentation here. So as the title of the talk goes about the sensor and actuator. Now, why this course or whatever we are talking about, why this is important? So, in fact, recently, if you just explore or if you just look around yourself, so we are increasingly talking about IoT or Internet of Things, right? And then we are also talking about cyber physical systems. So when like this IoT, cyber physical systems, so they become a buzzword. So in that case, so if I talk about the IoT, so Internet of Things, so as the name suggests that after internet, so you are placing a physical device, right? And similarly, when you are talking about whether it is Industry 4.0 or whether it is cyber physical system, so we are talking about increasing use of these sensors at all the places. And this is how it actually works, that you have a physical world and then you have a controller, that is the digital world. So you get a output signal and sensors, and then measure plant output, control effort, actuators, and input signal to the plant. So this is for a particular process control. Going back to some of the definitions here. So now, as I said, that you have seen the bigger picture, that what's the main objective. that is come up with some kind of a device or come up with some DIY project. So you may have already done it. If not done it, if you have not done it, because we have students here, and so you can just explore the things around and giving it a formal definition. So sensors and actuators can be put up in a broader category, that is the transducer. So transducer, we are saying any device that converts one form of energy to another. So whether it is sensor or whether it is actuator, so both are converting this energy, right? So however, if you look at the sensors, so in sensor what we are doing is that they measure the physical quantity. Like in the first case, in the first video you had seen, as the kid places his hand in front of the sensor, so the physical unit here is the distance, and then it converts that distance into the signal, that is a electrical form, and then this can be further read by the instrument. And what does that actuator do? So it's like an inverse relation. So for actuator, it is a device that actuates or moves something. Or in other way, I can say that again, actuator is also doing the conversion process, that is one form of energy to another. That is, it is converting electrical signal to the mechanical form for an actuator, because the mechanical form in this case was that it gets some voltage input, that is the electrical signal, and then it converts it into the pressure, and which is able to then dispense the liquid out. Whereas sensors, it is the opposite. Here you are getting say the physical input, or the distance was the input, or a physical quantity, and it converts it into the electrical quantity. So having said that, so if we look at a general classification of these sensors, so one way to classify the sensors is internal and external sensors. So, and since we deal with something like related to biomechanics, so I would like to mention here that even for our body, so we as a human body, we has lot of sensors. And if I try to give you an example for the internal and external sensors, so external sensor, you all know, so the sense of smell or touch or even the vision. So eyes are also a sensor. So external sensor is that which interact with the external environment or the physical world. Whereas there are certain sensors which are necessary for the working, but they do not interact with the physical world. So what are those internal sensors? So for example, if I take again the case of a human body, so as soon as you place your hand on something hot, so you get that signal. So you have that sense of touch, and then it sends some signal. So that is, you interact with the external environment. So you get some input and it works on it. So that is an example of external sensor. However, if you look at something like your pulse, or if you are talking about your blood pressure, so there is no interaction with the external environment. So for your heartbeat or the pulse, so there is no interaction with the external environment, but again, that is a kind of a sensor. So pulse is also a sensor in a way that as the pulse changes. So, you know, that would also, so, and this internal sensor, so until and unless you have a this blood pressure, proper blood pressure or a pulse rate, so this would again means it is essential for the survival of the human body. So same way we are saying for the sensors. So if we look at a physical system, it could be a process automation or anywhere. So again, you have these two types of sensors, internal and external sensors. So internal sensors could be something like position sensors. So if you have a CNC machine, so again, like you need some internal sensors or the position sensor to know like what is the tool head or what is the position of say the tool or the workpiece and things like. So internal sensors, these are kind of integral or absolutely essential for the working of system, and then you have this kind of a external sensor. And again, then depending on what is the loop that you are using to control this, that is sensor and actuator. So it could be an open loop system or a closed loop system. So then if we talk about the active and passive sensors, so in passive sensing, the sensor measures the energy that is naturally available. So if you talk about, say, the thermal, infrared, surface emissions, so it is using the energy which is naturally available. However, if you are talking about the active sensing, so sensors provide energy on their own as a source of the illumination. So again, this is like that the energy requirements, so whether you are using that energy with the whatever is available or some external, so it could be active or the passive sensing. Then quickly talking about, so since in this particular setup, you had seen something like accelerometer or gyroscope and some like force sensors. So if you look at the general or the broad classifications or the categories of these sensors, so they could be like motion sensors, that is orientation or inclination sensors. So what you were seeing there is actually a kind of a inclination sensor, a gyroscope. So even in your mobile phone or the screen, so you have this auto rotate feature. So it automatically, like as you change the orientation, so it changes from portrait to landscape and this thing. So you are using that inertial measurement unit there also. Then you have some kind like force, pressure or strain, then position, temperature, humidity, rotary position, and so on. Now again, why these sensors are important? So like if we look at that, how these sensors are affecting us in our day-to-day life. So as a technologist, you should appreciate that there was a lot of discussion about this Rafale aircrafts, that it being included in this fleet. And of course, we are always competing, or means China being our neighbor and kind of a competitor as well. Of course, they are at maybe at a more advantageous position. So if you compare this Rafale with J20 aircrafts or these Chinese aircrafts, so we talk about the stealth technology. So stealth technology is like something that this aircraft, so their ability to go undetected or unnoticed. So it is like when they enter into a different airfield. So naturally we want that this aircraft should not be detected by the enemy radar, right? So now if we are looking at that thing, so stealth technology, of course, one it could be like this. There could be some special kind of paints that could be there that allows it to go unnoticed. Or it is also, we are saying, application of some of these basic sensors. So it is like due to the shape of this or some of the basic sensors, or one of the best example of the sensors in your day-to-day life is as you come drive your scooter or a car, so you have a speedometer. So you know whether you are driving at 20 or 30 kilometer per hour or 40 kilometer, so on. So you are actually sensing this. And so that's also a kind of a sensor that is being placed there. So we are saying that sensors, they are there in our day-to-day life, and then we need to know. So again, whether it is or a two-wheeler, or whether it is a stealth or a fighter aircraft such as Rafale. So everywhere there are sensors, and then we are looking at that. So the and these are again not something very different. So talking about this motion that is around for the orientation, this thing. So here we have acceleration, gyroscope, compass, and tilt sensor. So basically, the unit that you saw in the third video, that is the research work that we were doing. So we are using combination of first, second, and the fourth one. So I'll show you some more videos for this accelerometer and this one. So again, here when we talk about the accelerometer, so you can have an industrial grade sensor. So something that would be costing around 1 lakh. To we have something that comes for say 700 or 800 rupees. So one that we use, so that is a MEMS based accelerometer, and that was something for a very low price. So let me show you. So this is how a accelerometer would look like. And okay, so I'll play this video. Just give me a second. I'm trying to play some videos I could have downloaded over there, but okay.
Sir, even the airbag opening system in the car uses that MEMS system, right, sir?
Yeah, so the safety bags, so that also uses the sensors or again, so MEMS sensors. So again, one is like these are very small, and then these are also cost effective.
Yes, sir.
Is the other screen that window now visible? Or still is it just the means presentation, PowerPoint presentation? Can you see the video now?
No, sir.
Okay, so that means I need to share this screen here. I'll share the screen again. Okay, so just give me a second. So I'm now going to this one here. Share. So this is the. So now I think you can see the screen, right?
Yes, sir.
So what we are seeing in this video is this is a plate or so this is a servo motor, and you can see this servo motor being controlled as he is moving this plate or as it's this plate is being tilted. So this is causing this or activating this servo motor here. So we look at that. What is actually the use of these sensors? So this one was a simple one. So let me show the other one, which gives a.
Sir, actually, how it is maintaining that vertical position, sir?
Yeah, so actually this is what we wanted to discuss here. So here you had seen earlier one system that I had shown, that is accelerometer and a gyroscope. So same inertial measurement unit. So this is being used in what we had seen this video. So that's why it's called a self-balancing. So it uses these accelerometer and the gyroscope because we are talking about some forces and angle or the rotation. So this sensor is actually detecting this, like as this is unbalanced or as there is this unbalance, so it accordingly gives that input to the the control, and that's accordingly, like there is a this feedback, and then it takes a corrective action. So the idea here was that we were talking about these initial sensors here, that is the tilt sensor, accelerometer, and the gyroscope. So the gyroscope, it actually measures the rotational, or that is what is the angle of the turn. Accelerometer, here we are talking about the acceleration or the motion. So these are working in tandem or together as a IFU, and then this is trying to balance this robot. So I've seen that this robot, it's actually on a single wheel. So otherwise, it's not possible to balance this on a single wheel like this. So the whole the system is trying to balance this together. Then similarly, we have something like a tilt sensing. So I'll just quickly play that part. So,
Hello, today we'll be showing the limitations of the accelerometer on the iPhone. To do this, we'll be using a free application called 3D Accelerometer by iPad Studios. First, let's show what the iPhone does do well. Let's start with the shake. Using the accelerometer, you can see the red dot moving and can be captured easily by developers. Secondly, the tilt or flip, also detected well using the angular movement. Unfortunately, the iPhone cannot detect linear movement. When the iPhone is moved slowly in any direction, notice the red dot does not move. This limits the developer's use of the iPhone, and as a result, the user experience on the iPhone. To do this, we will be using a free application called 3D Accelerometer by iPad Studios. First, let's show what the iPhone does do well. Let's start with the shake. Using the accelerometer, you can see the red dot moving and can be captured easily by developers. Secondly, the tilt or flip, also detected well using the angular movement. Unfortunately, the iPhone cannot detect linear movement. When the iPhone is moved slowly in any direction, notice the red dot does not move. This limits the developer.
Okay, so in this video, basically what we are trying to say is, so it is showing the limitation of that iPhone if you are talking about this red dot. So it says that as you have this linear movement, so you can see that there is no movement of this red dot. So that is our limitation.
Use of the iPhone. As a result, the user experience.
Okay, so now let me come back to the presentation here. Okay, this one.
Do you want to learn how to hack systems as an ethical hacker? Check this. I've used this Linux computer.
Just a second. So, okay. So I think now presentation, so you can see the presentation back, right? Am I audible?
Yes, sir.
Okay, fine. So, and as the presentation, you can see the presentation. Now again, let's switch to PowerPoint.
Yes, sir. Accelerator demo.
Pardon?
Sorry, accelerometer demo. Yeah, we can see the presentation.
Fine. Okay, thank you. So that's what we were talking about. So the whole thing, so it was using some this accelerometers and gyroscope, and we said that we need some combination of like the forces and say the rotational angles. So this is what this inertial measurement unit together with accelerometers and gyroscope is doing. So that is we are measuring this change in the angles, that is along x, y, and z. And so this is how it works. So I'm not going into the complete details of all these part. This is rather more of as an introduction to you that how we can use these sensors for different applications. Okay. Yeah. Then the next part is this is another interesting video that if I can, I'll not play the complete video, but quickly we can share this so that you understand that what is the next thing after this. So we have seen like something we are using this sensors and sensors, and then we are using the signal conditioning. So how do we use that further to improve our system? So share it out. One second. So is the browser this video visible now?
Not yet, sir.
You can see the video?
No, sir.
Okay. Okay, now it should be fine. So now you can see, right?
Yes, sir.
So I'll take it from the beginning. Of course, the computer monitor, it shows that this is a bit old video. So what we are trying to look at is the development process, that how we can improve upon the system. So first system is when the person is used only accelerometer for this self-balancing robot. Then the second approach is that accelerometer, it is used with some filter. So you can see like, so what we are looking at is that how we can improve or build upon the system. So then he is using another filter, that is Kalman filter. So initially it was just accelerometer. Now this is accelerometer, gyroscope, and filter. So it has a good stability. So then this is the fourth approach. Then again another filter, complementary filter with so you can see then this is able to climb a ramp using this system. Then finally they have made a larger system, so there is more weight onto this robot. And then okay, so that was about this demonstration. So now let me come back to the presentation. So you had seen in the previous demonstration that how when we are using some of this like these filters, and then so what is the effect that is it is doing, or like how we can improve the existing system. And then just to add on, like so first part was we were looking at one kind of sensors, motion sensors. Then you have other kind like force resisting or force sensing resistors. So these are something like you had seen the system, the one that I showed. So this is combining both the force sensor as well as the accelerometer and the gyroscope in this. So we have like done this combination of all this, and how like what is the next step? So as you can see here, that when we have these kinds of sensors, when you are working on some kind of a robotic system or exoskeletons, so if you have this basic idea that how you are using this knowledge to improve the existing system, so that is really going to be a great help. And that's what actually is required from us, that we use the theoretical background. So when you go ahead with any of this as a hobby, when you are doing these projects, so it has to be step by step. That is, you keep on implementing. So you come up with some system first, and then you look at that how this system can be improved further. So as I was showing in the previous thing as well, that is how the system that we developed. So we can use a Bluetooth module, and then how we can improve the data acquisition part of that. So this is just for like your understanding, if you can reflect upon this, that you had seen that this was the force sensor. So basically these are the force sensors which we have used also in this particular this arrangement. So the point here is that how we can convert the resistance into the measurement data. And if you are talking about that self-balancing system or a walking robot that balances itself, so how you use the force feedback sensors. So again, it's not a test here, but you can like reflect on these questions. So this is something, so this videos slide will be there. You can go later on, go and watch the other videos. That was the kind of sensor that we were talking about for the force sensor. So now quickly, I have another 5 minutes because the session was to be till 11 o'clock. So I'll just quickly go through. So first part we were talking about sensors, then we are talking about some kind of a data handling system, and then we are talking about some actuators. So when we look at this data handling system, so we are talking about the physical world, and then both data about the physical world and control signals sent to interact with the physical world are typically analog. So we understand that, or these are continuously varying quantities. Now, if you have to use something for a digital electronics, so you have to convert this from analog to the digital form and for the experimental measurement, and convert from digital to analog form on the output or the output end. So that's what we are talking about, that when we are talking about this data collection, so there is a measurement of a physical variable, and then you have ADC, analog to digital conversion, then digital to analog conversion, and then finally the control of the physical variables. So if you are talking about a power plant and you have a loop, so you take measurement on that input and then you converted it to some form and then you control that physical variable. And about this, some basics, that what is sampling, quantization and encoding. So we want to convert the continuous signal into a series of discrete analog signals at periodic intervals. And then how we are going to quantize this, or the sampling rate. So each discrete analog is converted into one of the finite number of discrete amplitude levels. And then encoding, here we are saying the discrete amplitude levels are converted into a digital code. So that was something like you have dealt with and like elaborate or extensively in the code base. And just to complete this discussion about the sensors and actuators. So we discussed one kind of a transducer, that is a sensor. Then we were looking at that the data measurement or handling, how do we go about it, and then we talk about the actuators. So as I said, the actuator is the reverse, that is here we are changing. So it is like you have the servo motor, so it gets an electrical input and it converts into a mechanical form. So actuator is a transducer, again changes one type of physical quantity into some into the physical form. And so this is something block diagram that you can use to understand this. And these actuators, again, like mostly we use with the electric actuators. So either it could be powered through electrical energy, or it could be a hydraulic energy, or it could be the pneumatic, as in like the compressed air. So of course, these different types, they have their own merits and demerits. So hydraulic and pneumatic, generally you'll not find it. So most commonly available are the electrical actuators. And of course, this is like one last concluding slide here, that which compares the open system and a closed signal. So that is here we have a sensor and an actuator and a feedback signal also being added to this. And that takes you to another part of the discussion, to like when we talk about the control. So like we were talking about, so that brings me to the conclusion of this discussion. So in the first part of the course, we had looked at something about means using LabVIEW. Then today's discussion, I wanted to give you an overall view that what is the next thing that you need to do, or how do you take it to some deliverable. And as I was saying that like we work on biomechanics, the setup that you had seen. So basically we that was to be used on some kind of a artificial limb that we have developed. And we were looking at that how we use these sensors to basically capture the data, which would be used for some kind of a mathematical modeling, or some making something for the design, that if I have to design an artificial limb, so how do I use this force and the signal data. So then the question here is that I have those sensors, and then how do you actually refine, because whatever I may be getting may not be very accurate. So how do I focus on the accuracy part? So you had seen, so as I say that as a mechanical engineer, so like that's not my forte. I do not know much about all this, but again, we are just trying to get things from here and there, and then trying to put it together so that ultimately you should be able to do something. and we are happy about like this particular setup. So if you go for like for a gate lab, so this would be something in lakhs, and then we cannot afford it. And then so one choice is that you sit and wait, and then try to find out some contact that okay, I can go to this lab and work there. And other thing is, thanks to these low cost systems that are now being available, that you can always get started, start working on something. So that is the whole idea about this particular session. That you look forward that now how do you take it to something that you will be doing further. So of course the software part, LabVIEW, you already have it. You also see that how you are going to take a next project using all this knowledge that's being covered till this part. So I think more or less I'm done. So if there are a few questions, so we can have a quick interaction. Yeah, so I'm done from my side. So you can, if you want to take some questions, so let me know.
Any questions? Any participants?
Hello. Hello.
Yeah,
Sir,
I can hear you.
Okay, sir. Okay. So I'm very interested in the first slide, sir. As you shown as a research work,
Yeah.
some student is doing some walking by using those sensors, placing on the waist. Right?
Yes.
So my question is that, sir, you have placed IMU on the leg. Like
yeah. So it was like if I go through this thing. So basically, it is there are accelerometers, and first is the foot part. So here it is the sole. So in the sole we have placed the force sensors or Flexi force sensors, and then in the upper part, if you see over there, so you have something here as well. So here we have used the accelerometer. So that is basically for the angle measurement. So the upper part we are using this.
Yes, sir.
Yeah. So this is connected using the Bluetooth module. So we are transferring this data to the mobile phone, and then we are getting those forces. So it's like you can put it in kg, you can calibrate the sensor. So we want to see that what is the distribution on the legs. So first part is the reaction force, then the other part is joint angles, that is for the foot and for the knee. So what is the rotation that is taking place?
Right, sir. I agree with that. That means I think you are using some gyroscope and accelerometer combination.
Yes. Yeah.
Okay.
So for the angle measurement.
Right. So is it a 6 degree of freedom system you had used here?
No. So this is actually, so the accelerometer that you get is, so these could be like single axis or triaxial. So
Right.
of course for the knee one we are using a single axis, though it is a triaxial accelerometer. But for the foot we are using it means both are the triaxial, that is 3 axis. You get rotation along X, Y, and Z. So but for the foot we are using all three, like we call it as roll, pitch, and yaw. So this is the roll, then this is say the pitch, and then this is the yaw. So these are the 3 rotations we are talking about. One is in the plane, one is in this plane, and one is in this plane. So for roll, pitch, and yaw, so this accelerometer, it captures theta along X, Y, and Z axis. And the other one for the knee, so we are capturing data only for along one axis.
Right, sir. Right. I agree with that. So somewhere, sir, I found in literature that 9 degree of freedom IMUs are not preferable for this kind of test. More preferable is 6 degree of freedom due to magnometers. Effect of magnometers. I think they are not getting proper readings in these experiments. Is it true? It means I did not got any correct justification of that statement in the literature. Somewhere I found that 9 DOF system is not preferable.
Like when we are talking about this degree of freedom, so like here what I'm referring to is because the accelerometer, so that is only 3 degree of freedom, that is you are measuring. So it is like at this joint. So now when you are talking about the degrees of freedom, so like you have first joint. So this is the first joint, right? So this is the first joint. Here you have one accelerometer which is measuring roll, pitch and yaw for this joint. Then you are looking at the second joint. So again, this is having another 3 degrees of freedom. So this is like when you say 6 or 9 degrees of freedom. So these are for all these joints together. So if I place one more sensor over here, hip joint, so then 3 degrees of freedom for this, 3 for this, or 3 for this. So these 9 are from the different sensors. So it is like with one accelerometer, you are using only 3 degree of freedom, or that is 3 rotations XYZ. And as I said, for the new one, we were using only one output, that is only along one rotation we are looking there.
Yeah,
so my point was that when you are looking at this IMU, like I also demonstrated one video where you had seen that tracking or a red dot tracking in a phone. So these have certain blind spot, like there you were seeing that for the linear displacement that red spot was actually not moving. So there are certain limitations for these IMUs and this. So you can like theoretically relate with it and then look at some kind of a check. Like that's what that was demonstrated in that video, where he's talking about that a tracking system on that iPhone screen. So that as you have a linear displacement of that phone, very slow movement, so that dot actually doesn't move. So you can look at some your own way to check when you know that actually this thing should move, and then it's not the output is not being reflected. So my point here is that it cannot be like foolproof thing that this is good or bad, because that depends on what is the accuracy. Like for the sensor we placed there, we needed only for knee joint only one kind of rotation. So you also try to come up with your own system where you can just have a check that whatever the claim is being made, whether that is correct or not. So that you will have to explore a bit that what kind of system you'll use. So you get that sensor or that IMU and then place it on some device, and then have some kind of your system develop a GUI and something with some visual. Because when we were using this gyroscope, so we had a simple visual display, like when I tilt this sensor, so it would simply show me on the screen that when I'm tilting the sensor, so it would show that what is the rotation. So I could correlate with that.
Okay. Thank you, sir. Thank you.
Yeah, and you can get in touch with us. So there's no problem. We can always help you. Like if it has not been answered here, so out of this or other than this course, then you are always welcome. And, get
Sure, sir. Have you published any research, sir, on this particular work till now?
So we are still working on it. So not sure.
Okay. Thank you, sir. Thank you.
Yeah. Thank you.
Sir, can you just text your mail ID in the chat box, sir?
Yeah, sure, I'll do that. Dr. Parikshit, you have the access?
Sorry, sir. Are you asking for me, sir?
Okay. No, that's fine. I'll do it. I'm just okay. I got the chat option. So
as I said, if we need for further assistance, just for to be in contact, sir. So
no,
I just asked.
Yeah, that's fine. So I'm just sending that. In fact, so this is asingh.mnit.ac.in. So
Yep,
that
got
is, and I'm also sending my number 954965.
Yes, sir. Got it, sir. Thank you, sir.
Yeah. So you want me to end the session now, or there are any more questions?
Hello.
Yes.
Hello. Sir, only one last question just came into my mind right now, so I'm asking.
Sure.
When a person is doing this kind of experiment, as you shown in the research, I think the hand should be close to the chest so that our center of mass should not be dislocated in the walking pattern, the gait cycle. I think it should be a proper gait protocol must be there.
Yeah, so that's actually not when I demonstrated that video, so we were just testing the system. So it was not that we were getting the gate data from that system. So we were just checking the system that whether it is working fine or not. So yes, you are right. So there are certain protocols like when you are making a person walk on for this measurement. So means you have to do it like for the heel strike, then toe off and mid stance. So that is there. Yeah. Thanks.
Thank you. Thank you very much, sir.
Thank you. So I'll stop this. I'll end the meeting now, right?